And here's the graph of j of x. Again, now you see in your notes, they're starting to give us graphs that we don't know the equation of. So our first couple of examples that we did the other day, we had x squared, x cubed, square root of x, absolute value of x. You still need to know all those parent graphs, but in these ones, they're saying, we're just giving you some random graph. We want to sketch the image after translation 4 units left and 5 units down. So what you're going to do is you're going to look for some key points. So I've got a key point there, a key point there, and a key point there. And say what would happen to those points if I move them 4 units to the left and 5 units down. Well, this first point at negative 1, 0, 1, oh, I'm moving both of those. Oh, that's fun. 1, 2, 3, 4. That moved both of those 4 to the left. And then I would move them 5 down. Wow. That is disastrous. Let's see. There. Let's do a double check. 1, 2, 3, 4. 1, 2, 3, 4, 5. Yes, they are in the right spot. And same thing with that top point. Oh, and now it is in between. So I move 1, 2, 3, 4 to the left and 5 down. It's going to match up right there. So once you figure out where those points end up going, you can show your graph. And again, even though the textbook ends it there, whenever the textbook ends it at the end of the graph, that does mean that that graph continues forever. So we need to put arrowheads on the end of it. So this example has a graph moving left, right, and up and down. And right before this example, in your notes, they have this generalization. What I want you to write right beside the box, either on the left or the right, is just take this minus k here, take that minus k and move it to the other side. Because we like to write things with y equals. So the h, that moves things left and right. The k, that moves things up and down. Whoops. Up and down. So now that we have this in mind, we can go back to our example. Because again, we need to write the equation of the image graph in terms of the function j. So it's an equation, so we need y equals. And we've moved 4 to the left and 5 down. So in terms of our function j, we're going to have something happen inside of our function and something happen outside of our function. The inside of the function, to move it 4 to the left, we'll have x plus 4. The outside of the function, to move it 5 down, we'll have minus 5. State the domain and range. On this one, I'll use set notation because I think that it's its turn. So for set notation for the domain, again, we think, what's the smallest value? And because there's arrows here, what this is indicating is this is indicating not only is it going up forever, it's also getting wider forever. So when you have arrows, it's doing two things. It's affecting your x values and your y values. So because it's getting wider forever, there is no smallest value. And because it's getting wider forever, there is no largest value. So for our domain, that means that it's everything. The way that we show everything in set notation, actually do both set and interval for you here. But set notation, we would say x belongs to the real numbers, means x is everything. For our range, we do have a smallest value. On our blue graph, it never goes below minus 5. So coming from the bottom up, we see that minus 5 is our lowest value, but there's arrowheads going up forever, so we can indicate that by just saying y is greater than or equal to minus 5. So right beside this in black, I will show you interval notation. So for everything in interval notation, you would write negative infinity to infinity with round brackets. And for y greater than or equal to negative 5, well, because it includes negative 5, it would be a square bracket, but it goes up forever, so go to infinity. Questions with this one are 8, 9, and 10, and we'll continue with this in period 3.